morning, dear students. In the last class, we discussed about Joule's law and we have done a lot of problems relating to it. Today, we are going to study a new topic. In the 9th standard, you have studied how you can arrange two cells in a circuit. In which all ways you can arrange two cells? Yes, in two ways, in series connection and in parallel connection. Today we are going to study how we can arrange two resistors in a circuit.
Before studying about the arrangement of resistors in a circuit, we need to know what is a resistor. We know that resistance is a measure of opposition to current flow in a circuit. Resistor is an electrical component that implements resistance in a circuit. We can represent a resistor in this way. This is a resistor with resistance R ohm. In this way, we represent a resistor. Then, do you know how a resistance or a resistor actually look like? This is a resistor. So by seeing the figure itself, we can say it is a two-terminal electrical component, or it have two legs. What are things we can see there? Yes, there are some color rings on the resistor. What does these color rings mean, or what is the use of these color codes? These color rings help us to find the value of resistance of the resistor. Based on these color rings, there are different types of resistors, or there are different resistors in these ways. All these are resistors of different value of resistance. The value of the resistance differ according to the color rings. Then, how can we find out the value of the resistance based on these color rings? This table helps us for that. Here some colors are given. These are the colors we can see on a resistor. They are black, brown, red, orange, yellow, green, blue, violet, grey, white. And two subsidiary colors are also given, gold and silver, that I will say you afterwards. For all these colors, a particular digit is given. For black, the digit is 0. For brown, it is 1. Red represents 2. Orange represents 3. Yellow represents 4. The number corresponding to green is 5. For blue, it is 6. For violet, it is 7. For grey, it is 8. And for white, it is 9. And some multiplier is given and tolerance is given. I will say you. If we have these color numbers and a resistor, how can we find out the value of a resistor? See, here we have a resistor like this. I have 3 color rings here and one in the right side. For example, the color of the first ring is blue. The color of the second ring is green. And the color of the third ring is red. Then, see, what is the color corresponding to blue? It's 6. What is the color corresponding to green? It's 5. What is the color corresponding to red? It's 2. So, we can write these numbers. The color corresponding to blue is 6, The color corresponding to green is 5. Just write these digits like that. For the third ring means it is the multiplier. That means what is the color? Find the digit corresponding to that color, place or multiply it with that much value of 10. That means into 10 raised to the color digit corresponding to red is 2, so into 10 raised to 2. This is the value of this resistor. I will say once more, the color corresponding to blue is 6, the color corresponding to green is 5, and the third ring or the third color represents multiplier. We have to multiply that much tens. So into 10 raised to the digit corresponding to red is 2, so 10 raised to 2 ohm. So we got the resistance value. But you can see there is one more color ring. What does this mean? This is the tolerance. Tolerance means from this actual value of resistance, the value can be changed to a certain limit. To a small limit, the value can be changed. This difference is shown by tolerance. For tolerance, we have three options. Either the ring can be gold, or the ring can be silver, or there is no such ring. It is shown here. If it is gold, the tolerance will be 5%. If the ring is silver, the tolerance will be 10%. And if there is no such ring, the tolerance is 20%. So we can see a figure. Here our ring is gold. So how the value will change? Our value will be like this. Resistance R is equal to 65 into 10 raised to 2 ohm plus or minus. For gold, it represents how much percentage? It's 5%. So plus or minus 5%. In this way, we will find the value of resistor. Then, now we can see the arrangement of resistors in a circuit, how it is arranged. Just like the arrangement of cells, resistors can also be arranged in two ways. They are series connection and parallel connection. What do you mean by a series connection? You have studied it for the cell connection also. When a circuit is completed by connecting the resistors one after the other, it is called series connection. That means here I have one resistor with resistance R1. Here I have another resistor with resistance R2. If these resistors are connected in this way and a cell is connected here, then we can say that the resistors are connected in series. The second one is connected just after the first. This is series connection. Then how we can connect two resistors in parallel? Here I have the first resistor with resistance R1 ohm, and here I have the second resistor with R2 ohm. If I connect both the ends together, this is a parallel connection. I can connect a cell here. So here two resistors are connected parallel in a circuit. These are the two ways of connecting two resistors. Then let's study the properties of connecting two resistors. Take the first figure in series connection. When the cell is connected, we know a current will flow through the circuit, let it be I. The I amount of current flows through the circuit, it reaches R1, it passes through R1, then it passes through R2. That means from the figure itself we can say that the same current passes through both the circuit. So remember this point, in a series circuit the current passing through both the resistors are same. I is same. Then second point, what about the potential difference? To find the total potential difference of the circuit, we can connect a voltmeter across these two ends. Then we get the potential difference as V volt. Next, I want to find the potential difference across the resistor R1. For that, I want to find out the potential difference across these two ends. Let it be V1 volt. And to find out the potential difference between R2, I want to find out it between these two ends. Let it be V2 volt. So from the figure itself, we can say that the potential difference between R1 and R2 is different. So note this point, when two resistors are connected in series, the potential difference between two resistors are different. Next, we can go to the next connection, parallel connection. What about the current? When the circuit is on, the current I flows through the circuit. When it reaches this junction, it have two paths. So, one amount of current passes through R1, let it be I1 ampere, and other part of the current flows through R2, let it be I2. So we can say that when two resistors are connected in parallel, the current passing through the circuit is different. Then, what about the potential difference? To find the potential difference across the cell or across the circuit, we can find out it by using these 2 points. Let it be V volt. Then how can we find out the potential difference across R1 resistor? See, this is the R1 resistor. This is the end points, or we can say that this is again the end points. It is V volt. Then for R2 resistor, again the end points is the same. So there is potential difference across R2 is also V. That means when two resistors are connected in parallel, the potential difference across two resistors are same. So we find the current and potential difference when two resistors are connected in series and in parallel. Next, we want to find out what will be the effective resistance or total resistance when two resistors are connected in series or in parallel. For that, let's draw the circuit once more. First, we can see series connection. Here also I have two resistors. named R1 and R2 with resistance R1 and R2. And I have a cell here with potential difference V. When the circuit is on, a current of I ampere flows through it. The potential difference across R1 is V1 volt and the potential difference across R2 is V2. We know the total potential difference V will be given by V1 plus V2. Then by Ohm's law we know V is equal to IR. Then what will be V1? Here we know the current I is same for both the resistors. So the current is I itself. What is the resistance for V1 potential? It is R1. Then what will be V2? It is IR2 because resistance corresponding to potential difference V2 is R2. This is our first equation. When we apply both these for our first equation, we have to add this to IR is equal to IR1 plus IR2. So IR is equal to, if we take I as common, I into R1 plus R2. We can cancel both the i's, so we get R is equal to R1 plus R2. That means the total or effective resistance when we connect two resistance in series is R1 plus R2. Next, we can consider the parallel connection. Here also I have two resistors with resistance R1 and R2. I connect both of them parallelly and we have a cell with potential difference V. That means the potential difference across R1 is V volt, potential difference across R2 is also V volt. Then what about the current? The current passing through the cell, the total circuit is I, and passing through R1 is I1 and through R2 is I2. So we know the total current I is divided into I1 and I2. So the total current I is equal to I1 plus I2. By Ohm's law, we know I is equal to V by R. For here, for I1, what can we write? The potential difference V is same for both the resistors. So V by first resistor is R1. Then what is I2? It is V by R2. We can apply both this in our first equation. So V by R is equal to V by R1 plus V by R2. V by R equal to, if we take the V as common, we get 1 by R1 plus 1 by R2. We can cancel both the V's. Then the equation will be 1 by R is equal to 1 by R1 plus 1 by R2. This is the effective or total resistance if we connect two resistors in parallel. By seeing the equation itself, see, for series connection, the total resistance was R is equal to R1 plus R2. For parallel connection, it is 1 by R is equal to 1 by R1 plus 1 by R2. By seeing the equation itself, we can say that the effective resistance is more when we connect two resistors in series.
In this class, we studied about the arrangement of resistors in a circuit. Resistors can be connected in two ways, in series and in parallel. If we connect two resistors in series, the current passing through the resistors will be same, but the potential difference will be different, and the effective resistance R is equal to R1 plus R2. And if we connect two resistors in parallel, the current passing through the resistors will be different, but the potential difference across two resistors will be same. The effective resistance 1 by R is equal to 1 by R1 plus 1 by R2. The effective resistance will be more if we connect two resistors in series. Hope you understand the